Hello friends, topic of this video is power transmission across country. After the chapter we are going to do textual question answers too, so watch it till end. Power generating stations are usually located away from cities or heavily populated areas. Nationwide supply network is called grid. Power from grid is distributed by substations according to the requirement of area. For example, industries will require higher voltage and school, offices and homes will require comparatively less voltage. A typical generator will produce 33,000 volts voltage and current of about 20,000 amperes. Voltage of 33,000 volts is stepped up to about 4 lakh volts using a transformer. Series of substations, this voltage is stepped down using transformer at a level which is needed by consumers. Current supplied in our homes is alternating current or AC. Since on large scale AC can be generated more efficiently than DC. Second main advantage is voltage can be stepped up or stepped down using transformers, which cannot be done with DC. Let us look at the reason for stepping up voltage for transmission. So cables are good conductors. They have to run long distances and the resistance offered becomes significant, and this leads to loss of energy due to heating effect of the current. Let's have a look at one example to see how power loss can be reduced. Let us have a look at two cables. Power input in both is 2000 watt. Resistance of both is 2 ohm. Voltage is different. One has voltage of 200 volts and another one has 2000. So the current passing will be 10 amperes in one and 1 ampere in second. Power loss can be calculated by using formula current square into resistance. So power loss in first cable is 200 watt and in second cable it is 2 watt. So we can see the difference. If voltage is stepped up from 200 to 2000, current passing through it reduces and hence the power loss too reduces. Two advantages of using transformers to step up voltage are: first, reduced power loss at higher voltage; second, current is reduced, so thinner, lighter and cheaper cables can be used. Two ways of running high voltage transmission cables across the country are overhead or underground. Advantages of using overhead cables is they are cheaper and easier to insulate. Air also acts as insulator. Second, costly digging operations are avoided. And disadvantages are they are not often allowed in densely populated areas or areas of outstanding natural beauty. Let us now have a look at textual question answers. Question 1. In main supply system, how are voltage changes made? In main supply system, voltage changes are made by using transformers. Explain. AC rather than DC is used for transmitting mains power. On large scale, AC can be generated more efficiently than DC. Main advantages: voltage can be stepped up or stepped down by using transformers. Transformers cannot be used with direct current or DC. Give examples of where underground transmission cables may be used instead of overhead ones despite the extra cost. In densely populated areas or in areas of outstanding natural beauty. Calculate power output of 4 generators in a typical large power station in megawatt. 1 megawatt is equal to 1 million watt. In a typical generator, voltage is 33,000 volts and current is 20,000 amperes. So power output of 4 generators is equals to 4 into power output of 1 generator, that is 4 into V into I. 4 into 33,000 into 20,000 watt equals to 2640 megawatt. In the given example, calculate the power loss if the power is sent at 20,000 volt. Power input and resistance are both same. Difference is voltage. Now it is 20,000 volt. We will first calculate current. I is equals to P by V, that is 2000 by 20,000, which comes to 0.1. So current passing is 0.1 ampere. We can calculate power loss. Power loss is equals to I square R. 0.1 square into 2 gives us 0.02 watt. Power loss is equals to 0.02 watt. So we can observe again, if the voltage is increased, current passing through the cable reduces, reducing the power loss. Our next and last question of the video is, 4K power is fed to a transmission cable of resistance 5 ohm. Calculate power loss in the cable if the power is transmitted at 200 volts and 2 lakh volts. Power supplied is equals to 4 kilowatt, that is equals to 4000 watt, and resistance is 5 ohm. And formula we will be using are power is equals to voltage into current. Power loss is equals to I square R, current square into resistance. We will first calculate power loss at 200 volts. P is equals to VI, so 4000 equals to 200 into I, which gives us current of 20 amperes. So power loss is equals to I square R, that is 20 square into 5, which gives us 2000 watt is the power loss. Next we will calculate power loss at 2 lakh volts. First we will calculate current. Current we are getting 0.02 amperes. Power loss is equals to current square into resistance. So 0.02 square into 5. That gives us power loss of 0.002 watt. That's all in this video. Thank you for watching.